the relationship between beta and gamma function. This is frequently asked in examinations. We are asked to prove beta mn is equal to gamma n divided by gamma m plus n. We have to prove this where m is greater than 0, n is greater than 0. So for proof, we proceed by the definition of gamma function. That is, gamma n is equal to integration from 0 to infinity e raised power minus x raised power n minus 1 dx. Now if we equate the values in this integral, we get the different property of gamma function, that is equal to gamma n is equal to z raised power n 0 to infinity e raised power minus zx x raised power n minus 1 dx. This is by property. So this, we can write this as gamma n by z raised power n is equal to 0 to infinity e raised power minus zx x raised power n minus 1 dx. Let's name this as 2 and this by 1. So we have this equation 1. We will multiply both sides by z raised power m minus 1 and e raised power minus z, and then we'll integrate both sides from z equal to 2 and z reaching to infinity. So multiplying both sides by z raised power m minus 1 and e raised power minus z, and then integrating with respect to z from z equals 0 z reaching infinity. Okay, so this equation 1. Okay, this gamma n will stay as it is, and we have to multiply both sides by e raised power minus z and z raised power m minus 1. Then we have to integrate it from 0 to infinity. Okay, oh, this is LHS. Now dz is equal to, how will RHS be? It will be, first of all, we will multiply by 0 to infinity e raised power minus z raised power m minus 1. Then we will write this term as it is, that is z raised power n e raised power minus z x raised power n minus 1. This is dx, and then integrating it with respect to dz. Now we can write this, this is gamma n. This, if we see, this is our this is here the value is n, here is m, then it is gamma m. That will be equal to 0 to infinity e raised power minus z, and minus z will take minus z is common, then we'll get 1 plus x. Then we have z m n, we'll write it as z m plus n minus 1 and x raised to power n minus 1 dx dz. So in these equations we can rearrange the order of integration here. So we'll write it as so changing the order of integration, we'll write it as 0 to infinity, since x n minus 1, okay, because this is in terms of x, we'll write it as, and then we will write 0 to infinity e raised to power minus z 1 plus x z raised to power m plus n minus 1 with respect to the dz z and then dx. Now we will compare this with respect to our second equation. Here it is with respect to x and here it is with respect to dz. So here it is x raised to power n minus 1, here it's n, and here n is equal to m plus n. So applying this we'll get the value as 0 to infinity x raised to power n minus 1. This will be equal to, because here n is we can write it as m plus n, that is gamma m plus n divided by, here it is with respect to z and जो इसके साथ है that's 1 plus x, then we have to write it as 1 plus x whole raised power जो ऊपर लिखा हुआ है m plus n dx. This is gamma m gamma n. Now since this is the constant, ये हम यहाँ ले जाएंगे, that's gamma m gamma n divided by gamma m plus n is equal to 0 to infinity x raised to power n minus 1 divided by 1 plus x m plus n dx. So by the definition of beta function, we know beta m n is equal to 0 to infinity x raised to power n minus 1 1 plus x m plus n dx. We'll name it as 3, we'll name it as 4. We'll compare it and we'll get beta m comma n is equal to gamma m gamma n divided by gamma m plus n. Now from this gamma equation we'll prove an important result, that's gamma pi is equal to gamma 1 by 2. So by gamma by the relation we have beta m n is equal to gamma m plus gamma n, that is gamma m plus n. Also beta m n is equal to 2 integration from 0 to pi by 2 cos theta 2m minus 1 sin theta 2n minus 1 d theta. So from these we'll compare them and we'll take m is equal to 1 by 2. If we take m is equal to 1 by 2